This lesson is on permutations and combinations. Again, we're going to be looking at lots of different pieces that relate to permutations and combinations. The first is the multiplication counting principle. All right, so that says if there are m ways to make your first selection and n ways to make the second selection, the multiplication counting principle says you'll multiply them to get the total ways of selections. Okay? So for example, if we had a pizza shop that had 8 veggie toppings and 6 meat toppings, how many combinations can you order with 1 meat and 1 veg? Well, how many options, how many selections for the first, for the meat? There are 6 options, and we're going to multiply it by the second selection, 1 veg. There are 8 options for that, so there are 48 combinations of 1 meat and 1 veg. Okay. That's combination. Now if we look at permutation, okay, you have this vocab word. It's an arrangement in a specific order. So if I was looking at the number of arrangements, the specific arrangements for A, for B, and for C, I want to know how many specific combinations there are. Well, I can do obviously A, B, C. I can do A, C, B. I can do B, A, C, or B, C, A. I can start with C, A, and B, and C, B, and A. So in a specific order, and nothing there repeats. All right? Now, let's look at another example for permutation. Let's talk about different batting orders. With 9 players. So how many options are there for the first one? There's 9 different players I could choose from for the first batter. And then I'm left with 8 batters to choose from for the second batter. And then 7 and so on. 6 options available, then 5 options left, 4, 3, 2. And after I've picked the first 8, there's only 1 person left for that last batting order spot. And so I multiply all those together. There are 362,880, obviously you can use a calculator for that, options for different batting orders given 9 players. So the next thing we're going to look at is permutation notation. So this is the permutation of n. That's a little n, a big P, and a little r. Means the number of permutations of n objects. That's what the n is, the objects. Arranged R at a time. Okay? So what that means is if I had 8 songs, and I wanted 5 of those songs on a demo, how many specific orders could I have those 5 songs in, given there are 8 possible songs? So I have N, PR, this is what the equation looks like. Okay, it's N factorial, and we'll look at what that means. That's what the exclamation point is, over N minus R factorial. Okay, so the number of objects over the number of objects minus R at a time. How many at a time? So let's say we have this 8 is that first, the total, right? The permutation of 5 down there. Okay? It's going to look like 8 factorial over 8 minus 5 factorial. What does factorial mean? It means those combinations, this permutation right here. So 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 divided by 8 minus 5 is 3 factorial. Okay, so 3 times 2 times 1. All right, so we can put that in the calculator. So the top multiplied together is 40,320 over 6. So there are 6,720 specific orders for those 5 songs that are going on the demo. There's also a way to put it in this calculator, and we will check that when we get back to class. All right, the next and the last thing that we're looking at is combination notation. Which is similar to this permutation notation. It's NCR, so the number of combinations of n objects chosen are at a time. So this looks like NCR, which is n factorial over r factorial times n minus r factorial. Yes, Cambry, you're going to have to memorize these also. So we have an example, let's say 20 people report for jury duty. And I want to know how many combinations, let's say 12 person combinations of juries can be chosen. Okay. So we have the number of objects. There are 20 people, so that's my N. Combinations of R at a time, we're going to say 12 at a time. So that's 20 factorial over 12 factorial times 20 minus 12 factorial. We can simplify this bottom as 20 over 12 factorial times 8 factorial. And we will learn how to put that in a calculator, but in the meantime, you can do 20 times 19 times 18 times 17, so on and so forth, just like we did here, over, and this vice versa. We have 125,000 970 possible combinations, just given 20 people, and we want combinations of 12 people. The code word for this lesson is chicken. If you have any questions, feel free to email me. Your left-hand page are these. Okay? So go ahead and pause those videos and copy these down. Make sure that you are using a calculator for those permutations and combinations notation.